Download this code from codegive.com, link in the description below. A deep dive into Pluto TV split screen bugs and potential solutions, with hypothetical code examples. Pluto TV, like any complex software application, is prone to bugs. One particularly frustrating issue is the split screen bug, where the video content is either duplicated or distorted, appearing as if the screen is split into two or more sections. This tutorial will explore the potential causes of this bug, how it might manifest, and, importantly, how a developer, even without access to Pluto TV's code base, could approach diagnosing and potentially mitigating it, especially in a context where you might be developing a similar video streaming application or integrating with Pluto TV through an unofficial API. Disclaimer **: I don't have access to Pluto TV's internal source code. This tutorial provides educated guesses and hypothetical examples based on common video streaming issues and debugging strategies. I also cannot condone or encourage any activities that violate Pluto TV's terms of service or that could compromise their service. The code examples are meant for illustrative and educational purposes only. Understanding the split screen bug. Before we dive into code, let's break down what the split screen bug could be and the underlying issues that might cause it. This is crucial for formulating effective troubleshooting steps. Manifestation. The bug usually presents in one of the following ways. Duplicate video. The same video frame is rendered side by side or stacked. This can be horizontally or vertically split. Misaligned video. The video is distorted, with sections of the frame offset from their correct positions. It might look torn or shifted. Interlacing artifacts, especially on older TVs. While less common with modern TVs, the video might exhibit prominent lines due to incorrect interlacing handling. This often looks like horizontal bands. Aspect ratio issues. While not technically a split screen, incorrect aspect ratio handling can make the video appear squashed or stretched horizontally, which might be mistaken for a split screen. Potential causes. The root causes of this bug can stem from several areas. 1. Video decoding issues. Codec incompatibility. The device, example smart TV, streaming stick, browser, may not fully support the video codec used by Pluto TV, example H.264, H.265/HEVC, VP9, AV1. Decoding errors. The video decoding process itself might be buggy, leading to frame corruption or incorrect rendering. Hardware acceleration issues. Problems with hardware acceleration can cause decoding to fall back to software, which might be slower and more prone to errors. Multi-threading problems. If the decoder uses multiple threads for faster processing, synchronization issues between those threads could lead to data corruption and visual artifacts. 2. Rendering pipeline problems. Incorrect viewport configuration. The viewport, the area on the screen where the video is rendered, might be configured incorrectly, leading to the video being drawn multiple times or misaligned. Shader errors, especially with WebGL. If Pluto TV uses shaders, graphics programs, to manipulate the video, errors in the shader code can cause visual distortions. Double buffering issues. Problems with double buffering, using two buffers to prevent tearing, could cause the video to be rendered to the wrong buffer or to be displayed before it's complete. Synchronization errors, with VSync. If the video rendering isn't properly synchronized with the screen's refresh rate, VSync, tearing and other visual artifacts can occur. 3. Delivery and network issues. Corrupted video data. If the video data is corrupted during transmission from Pluto TV's servers to the user's device, the decoder will struggle to produce a valid image. Asterisk packet loss. Asterisk significant packet loss can lead to gaps in the video stream, which might be interpreted as errors in the decoding or rendering pipeline. Asterisk adaptive bitrate streaming issues. A buggy abridged algorithm could switch to a lower quality stream that exacerbates existing decoding or rendering issues, especially if the lower quality stream uses a different codec. 4 platform-specific bugs. Asterisk browser issues. Bugs in the browser's HTML5 video implementation or WebGL support can cause rendering problems. Operating system issues. Problems with the operating system's graphics drivers or multimedia framework can interfere with video playback. Hardware limitations. Some older or less powerful devices may simply lack the resources to decode and render high-resolution video smoothly. 2. Debugging strategies, hypothetical scenarios. Since we can't directly debug Pluto TV's code, we need to approach this from a black box perspective. We'll assume we are developing a similar video player or integrating with Pluto TV through an API, even if unofficial, and encounter similar issues. These strategies could potentially help isolate the problem if you are in such a situation. 1. Isolate the problem. Reproducibility. Can you consistently reproduce the bug? If not, it might be a transient network or server-side issue. Device specificity. Does the bug only occur on certain devices, example a specific smart TV model, a particular browser? This points to a platform-specific problem. Content specificity. Does the bug only occur with certain channels or on-demand content? This suggests a problem with the encoding of that specific video. Network conditions. Does the bug occur only when the network connection is weak or unstable? This suggests a network-related issue. Software versions. Does the bug occur with a specific version of the Pluto TV app or browser? This suggests a regression bug, introduced in a recent update. 2. Simulate a basic video player, code example. Let's create a simplified HTML5 video player using JavaScript to get a baseline understanding of how video rendering works. This allows you to test various scenarios and experiment with potential fixes. This code provides a basic HTML5 video player. You can load local video files into it. This is useful for testing. Codec support. Try different video files encoded with various codecs, example MP4 with H.264, WEBM with VP9. If the split screen issue only occurs with certain codecs, you've identified a potential codec incompatibility problem. File corruption. Intentionally corrupt a video file slightly and see how the player reacts. This can help you understand how the player handles corrupted data. 3. Simulating network issues, code example, needs server-side assistance. You can simulate network issues to see if they contribute to the split screen bug. This requires a bit more setup, involving a simple server-side component. Here's a conceptual outline and a simplified JavaScript example that relies on a hypothetical server endpoint that introduces artificial delays. Server-side, conceptual, example in Node.js. The server would stream the video file, but with artificial delays, packet loss simulation, or bandwidth throttling. Client-side, JavaScript, modified from previous example. Explanation. API URL, this points to a hypothetical server endpoint, /video stream, that streams the video. The query parameters delay and packet loss are used to simulate network conditions. You'd need to implement this on your server. The rest of the code is similar to the previous example. Important asterisk building a server that can accurately simulate network issues requires more in-depth knowledge of network programming and video streaming. Libraries exist in various languages, like Node.js, Python, that can help with this. The key is to introduce realistic delays, packet loss, and bandwidth limitations. 4. Inspect the rendering pipeline, if using WebGL or Canvas. If you are building a video player using WebGL or a Canvas element, you have more direct control over the rendering pipeline. This means you can potentially inspect the textures, shaders, and frame buffers to identify issues. WebGL Inspector Tools Browser developer tools often have WebGL inspectors that allow you to examine the state of the WebGL context, including textures, shaders, and frame buffers. Look for any anomalies in these elements. Shader debugging If you suspect a shader issue, try modifying the shader code to isolate the problem. For example, you could try disabling certain shader effects or changing the color output. Frame buffer analysis Examine the contents of the frame buffers used for rendering. Are the video frames being drawn correctly to the frame buffer? 5. Logging and monitoring Implement detailed logging throughout your video player code. Log information about decoding events log when a video frame is decoded, the size of the frame, and any errors that occur during decoding. Rendering events log when a video frame is rendered, the viewport size, and any errors that occur during rendering. Network events log network requests, response times, and any errors that occur during network communication. System resources monitor CPU usage, memory usage, and GPU usage. High resource usage can indicate a performance bottleneck that contributes to the bug. Collect this log data and analyze it to identify patterns and anomalies that might be related to the split screen bug. 6. Platform-specific considerations Browser issues Try different browsers, Chrome, Firefox, Safari, Edge, to see if the bug is browser-specific. If it is, try updating the browser to the latest version or disabling browser extensions that might be interfering with video playback. Operating system issues Try updating your operating system and graphics drivers to the latest versions. Hardware limitations If you are using an older or less powerful device, try lowering the video quality to see if that resolves the issue. 3. Hypothetical code examples, Advanced, WebGL-based player. Let's imagine you are building a custom video player using WebGL. This gives you direct control over how the video frames are rendered. This example illustrates how you might diagnose rendering issues. Explanation and debugging tips in this WebGL example Viewport check ensure that the GL viewport is configured correctly. The viewport should typically match the size of your canvas element. An incorrect viewport can cause the video to be drawn multiple times or misaligned. Text keyword check verify that the texture coordinates, A_textcoord in the vertex shader, are correct. Texture coordinates specify which part of the video frame should be mapped to each vertex of the rectangle. Incorrect texture coordinates can cause the video to be distorted. GL errors use GL getError to check for WebGL errors after each draw call. WebGL errors can provide valuable clues about what's going wrong. Common errors include GL invalid operation, GL invalid enum, and GL out of memory. Consult the WebGL documentation for details on these errors. Shader debugging If you suspect a shader issue, try commenting out parts of the fragment shader to see if that resolves the problem. You can also use a WebGL shader editor to debug your shaders in real time. Texture debugging. Use the browser's developer tools to inspect the contents of the video texture, video texture. Is the video frame being uploaded to the texture correctly? 4. Mitigation strategies, potential, if you had control of the player. If you were developing the Pluto TV app or a similar video player, here are some potential mitigation strategies based on the identified causes. Codec fallback. Implement a codec fallback mechanism. If the primary codec, example H.265, causes issues, try falling back to a more widely supported codec, example H.264. Error handling. Implement robust error handling throughout the video decoding and rendering pipeline. Catch exceptions and log them for debugging. Try to gracefully recover from errors without crashing the player. Adaptive bitrate streaming, abridged. Improve the abridged algorithm to be more robust to network fluctuations. Avoid switching to lower quality streams that exacerbate existing decoding or rendering issues. Hardware acceleration control. Provide an option to disable hardware acceleration. This can help identify if hardware acceleration is causing the problem. Platform-specific patches. Apply platform-specific patches to address known bugs in browsers, operating systems, or graphics drivers. User reporting. Provide a mechanism for users to report bugs and provide feedback. This can help you identify issues that you might not be able to reproduce in your own testing environment. Conclusion. Debugging video playback issues, especially in a black box scenario, is a challenging task. By understanding the potential causes of the split screen bug, simulating video playback in a controlled environment, and inspecting the rendering pipeline, if possible, you can increase your chances of identifying the root cause and implementing effective mitigation strategies. Remember to focus on isolating the problem, logging everything, and testing thoroughly. And always respect the terms of service of the platform you are interacting with.